Hello, chemistry students. Mr. McKee here, and I'm going to go over our first part of mole conversion problems. Today we're going to learn how to convert from moles to a specific number of atoms. So if you're still not entirely clear about what a mole is, I encourage you to check out the more in-depth introduction to a mole video, which can be found at the study links and also on the chemistry calendar. But today I'm just going to briefly review with you what a mole is. So the word mole is just a word that refers to a particular amount of something. The word is kind of like a dozen, which always refers to 12 of something. You can have a dozen apples, you can have a dozen cars, or you could have a dozen atoms. Similarly, the word mole always refers to 6.022 times 10 to the 23 of something. And in chemistry, we're usually talking about atoms or molecules. Here at the start of the year, we're going to be focused on atoms, but later on in the year, we'll learn that you can also have a mole of molecules. Okay, so it's a really big number, so you'll notice that we use scientific notation. Otherwise, you'd have to write out 23 zeros, which would be a pain and make us more prone to error. Remember, we use scientific notation for really big numbers and also really small numbers. And again, I have a video that teaches us about scientific notation. If you're still not comfortable with using it, you will want to watch that video. So as I said, we're going to start with converting between moles and atoms. So let's just jump right into the examples here. Example 1 says how many atoms in 2.3 moles of nickel. And we're going to use the same tables that we use throughout the year with the train tracks. Our process is going to be the same as if we're converting between metric units. In this case, we are starting with 2.3 moles of nickel, and we are trying to convert to atoms. So we're going to put that into our starting number in unit. 2.3 moles is what we're starting with, and we're trying to figure out how many atoms that is. The relationship we're going to use, also known as the conversion factor, is always going to be the same for any element, and that relationship is 1 mole is equal to 6.022 times 10 to the 23rd atoms. And you can see that right here. And we're going to plug that in down in our train tracks, as we always do with conversion factors. And we're going to use it to convert from moles into atoms. So just like we did earlier in the year, we have to arrange our conversion factor so that we are able to cancel out the unit that we're trying to cancel out. In this case, that is moles. So we put the moles on the bottom in our conversion factor. And again, that enables us to cancel it out because it appears on both the top and the bottom. And that leaves us with our answer in atoms, which is the goal. And we plug this into the calculator. We multiply 2.3 by 6.022 times 10 to the 23rd atoms. And for an answer, you should end up with 1.4 times 10 to the 24th atoms. Using scientific notation in the calculator can be tricky. So if you're having trouble with that, check out the video on the study links where I show you how to do that in the class calculators. Okay, the other thing to make note of here is significant figures. Remember that conversion factors are always definitions, and so we kind of ignore the number of significant figures in the conversion factor because those aren't measurements, they are definitions rather. So the only thing that we're looking at here is our starting number, which has 2 significant figures. And so that tells us that our answer should also have 2 significant figures, which it does here. 1.4 is 2 sig figs. So make sure that you round your final answer to 2 significant figures if that's what the input has. Okay, pause the video and try the next one on your own. Okay, hopefully you have now tried the U-Tri here. So let's go through it together. We're starting with 1.2 moles of sodium, and we're trying to figure out how many atoms that is. So that is our ending unit. The relationship between these is always the same. It is going to be 1 mole of whatever the element is, in this case sodium, is equal to 6.022 times 10 to the 23rd atoms of sodium. Notice that I abbreviated atoms there with a lowercase a. Feel free to do that also. So I'm going to put my starting number and unit down in the train tracks as it always does. It's going to go right here. And now I'm going to multiply by my conversion factor. And I want to cancel out moles of sodium, so I'm going to put that on the bottom of my conversion factor. 1 mole of sodium. On top, I'm going to put what that 1 mole is equal to, which is 6.022 times 10 to the 23rd atoms of sodium. Arranging the conversion factor like this allows me to cancel out moles of sodium and leaves me with an answer in atoms of sodium. And that answer is 7.2 times 10 to the 23rd, quite a few atoms of sodium there. Notice my answer has 2 significant figures, and that is because my starting number had 1.2, had 2 significant figures, that is. Okay, moving on to our second example. In this case, we're going in the other direction. We're going to be converting from atoms to moles, but let's read the question. How many moles would 4.5 times 10 to the 30 atoms be? So you've been given 4.5 times 10 to the 30th, and we're trying to figure out how many moles that is. So my starting number in unit is 4.5 times 10 to the 30th, which goes down here in the train tracks as always. And my ending unit is moles. So if you want, you can go ahead and put that where your answer is going to go at the end there. As always, the relationship between these two is 1 mole equals 6.022 times 10 to the 23rd. Again, notice it doesn't matter what element we're talking about here. It's always going to have that same relationship. So now I'm going to arrange my conversion factor so that I can cancel atoms out. So this is different than the last problem we did. So atoms goes on the bottom here, and moles goes on the top. Now I plug everything into the calculator. 4.5 times 10 to the 20 times 10 to the 30th times 1 divided by 6.022 times 10 to the 23rd, and I should get 7.5 times 10 to the 6th moles. Again, notice my answer has 2 significant figures, and that is because my starting number had 2 significant figures. We ignore the significant figures of the conversion factor in these kinds of problems. Okay, pause the video and try the next one. Okay, here is the solution to the U-Tri. First of all, read the question and be clear about what you're trying to do. How many moles would 1.23 times 10 to the 15th atoms be? So you've been given the number of atoms, and we are trying to convert that into moles. This is a one-step conversion problem. So my starting number in unit is 1.23 times 10 to the 15th atoms of oxygen. My ending unit is moles of oxygen. So as always, the relationship between atoms and moles is 1 mole of oxygen is equal to 6.022 times 10 to the 23rd atoms of oxygen. So I'm going to put my starting number and unit down here in the train tracks. 1.23 times 10 to the 15th atoms of oxygen. And I'm going to arrange my conversion factor right here so that I can cancel out atoms. So I'm going to put atoms on the bottom, 6.022 times 10 to the 23rd atoms of oxygen. Excuse me. And on top, 1 mole of oxygen. Arranging it like this allows me to cancel out atoms of oxygen and leaves me with moles of oxygen as my unit. So to solve this, I times on top 1.23 times 10 to the 15th multiplied by 1, which of course doesn't change anything. And then I divide by 6.022 times 10 to the 23rd, and I should get 2.04 times 10 to the negative 9th, which is a really small answer. That means I've got way less than 1 mole of oxygen here. Notice in this case, my answer has 3 significant figures, and that is because my starting number had 3 significant figures. Okay, hopefully that was helpful to you. Let me know if you have any questions and reach out. Have a great day.